ozone in the stratosphere. What do you know about it? We know it's O3. What do you know about ozone in the stratosphere? Hello. Thank you. It's a shield us from what? Sun. We're going to be a little bit more specific. What kind of rays come down from the sun? UV rays. So it shields us from ultraviolet rays, okay? It's found in the stratosphere. If it's found, I should say if, it shields us from ultraviolet radiation. When ozone, O3, is in the troposphere, what did you learn about that? It's not healthy. It's a greenhouse gas. It also contributes to one more problem. So it traps heat on Earth. UV rays come down, infrared rays get re-radiated back up. If ozone is in the troposphere, heat rays come right back down to Earth. If ozone is in the troposphere, something else can happen if it reacts with specific gases and the sun. What's it called?
Specific gases and the sun.
During traffic time, mainly in LA, smog. Ozone is one of the key components to photochemical smog with nitrous oxide and UV rays, okay? So ozone in the troposphere, not good. It's even toxic, okay? In the stratosphere, it's amazing. We need ozone in the stratosphere. And sadly, there's a big hole of this layer that's supposed to be there to protect you from UV rays, which is why now you wear sunblock. Because sunblock is the protector that you can add to your body to protect you from UV rays, which ozone is supposed to do, because it's not doing it, right?
So you think as time goes?
Ozone has specific molecules that are causing the hole. I should say, there's specific molecules that are causing a hole in the stratosphere where ozone should be highly concentrated. That's a better word. The main ozone depleting compound is, anybody know? If you look at this, something floral, you're good. So we've got, what's this? Good. Chlorofluorocarbon. And I made the name with those colors so you can look at the compounds. You've got chlorine, you've got fluorine, you've got carbon. Excuse me. One of these components in this molecule is going to do the massive amount of damage, which is the chlorine. And we're going to learn about this. Chlorofluorocarbons, like carbon dioxide, are persistent compounds. So they're a greenhouse gas too. Remember that. So there's a connection. There's one common thing so far. Chlorofluorocarbons are greenhouse gases that contribute to warming of Earth, and they contribute to ozone depletion. Ozone gas is a greenhouse gas, and it is the layer of protection during in our stratosphere from UV ray. So there's another connection, okay? Both greenhouse effect and ozone depletion start with UV rays. The difference is greenhouse effect, infrared rays are the key contributing factor to the warming. UV rays are the key contributing problem with the hole in the ozone. So we don't have to worry about infrared rays when we talk about ozone. So what are the key contributors to CFCs? What's this?
Hairspray?
Aerosol cans. Specifically hairspray. We had a panic time in the 80s about this. What's this?
Oh, vents. Oh, refrigerator, electric.
Coolants. Okay? Anybody that's in the industry of air conditioning and refrigerator has a lot of problems now trying to get Freon. It's like almost impossible to get because it contains CFCs. What's this?
Oh, butter. Wait, no.
No. It's squishy. They put it in packaging material. Foam. Foam contained. And notice I keep saying contained. Do you hear me saying that?
Yeah.
Ozone depletion is such a big problem that there's no more CFCs in any of these products, okay? And solvents contain CFCs. So aerosol cans was the biggest concern because we all use them, okay? It's not like you buy foam all the time. You get packages that have foam, right? You have refrigerators that have coolants, But you don't really see that versus aerosol cans. So this was a big scare for people because how are they going to have their products without aerosol, right? If you look at a can today that's aerosol, it says ozone friendly, or it'll have some kind of symbol, no CFCs or something of that nature. Here are some other contributors to ozone depletion. I promise you, the biggest concern and the only thing that usually pops up on the AP exam is CFCs. But you want to be familiar that, I mean, this is another word that's popped up. Any kind of chloride or fluoride, okay? These never pop up. These do, again, because here's your compounds that kill, hydroborofluorocarbons, okay? And then the latest, which is very scary, is the nitrous oxide. So we learned during greenhouse effect that nitrous oxide is persistent. So it's like CO2, it's persistent. That means when it's in the troposphere, nothing reacts with it. So eventually it could keep going up, and end up in the stratosphere. And if it ends up in the stratosphere, it's actually going to contribute to the depletion of ozone. And remember that these are the activities on land that produce nitrous oxide. Burning of fossil fuels, agriculture or industrialized agriculture. So it's definitely being emitted. Give you all the notes written where it makes more sense. So what's this molecule? Number one, ozone depleting molecule. Chlorofluorocarbons. What I want you to know is that UV rays are the only thing that break this molecule up. So CFCs were produced when in the 80s people would spray their hair so that their spikes can stand up in excess, and then all these CFCs were being emitted into the atmosphere, emitted. Nothing breaks it up. So it floats, it makes it to the stratosphere, and then when a UV ray hits the CFC molecule, what happens? Look at this picture. A chlorine is lost. Now this equation, you do not have to know the balanced equation. You just have to know that CFCs are hit by UV rays and a chlorine is a free-floating chlorine breaks off. We don't even want to know what this is. We don't care. We just want to know about this. What's going to happen? I'm going to call this step 2. We're going to call this step 1, and this is step 2. It's like if it was a 3-part reaction. What happens in step 2? Good. Chlorine reacts with ozone. We know it's ozone because it's O3. Then what happens? Good. So what happened here? What happened right now in step 2? So what happened? There's no more ozone. It broke ozone. It took an oxygen from ozone, formed, here you have to know, chlorine monoxide and oxygen gas. Okay? No more ozone. That's what you want to add to this part of the equation. No more, whoa. No more ozone. That's it. The whole began. Okay? I'll make this a different color. Now what? Step 3, we're going to call this. An oxygen that just happens to be floating around the stratosphere. How? Who cares? It's just there, right? Collides with what? Chlorine monoxide. What happens next? What's this? O2, which is what? Oxygen gas, what we like, right? Forms. What's this? The chlorine. What do you think is going to happen now? Whoops. It's going to go back and go find another ozone and do this again and then come back here and then here and here and here and here. And one single chlorine can destroy 100,000 ozones. It is not a positive feedback loop because if it was, it would have to go back here. Chlorine would have to produce CFCs. That's not what's happening. Question.
Two oxygens come together and kick out the chlorine.
Because oxygens like to be with other oxygens. That's a strong connection. They want each other, right? So they come back together because that's what likes to happen. And then the chlorine goes and it's free to destroy more ozone. Ozone depletion, ozone hole, disaster.